Welcome to Geometry 2, Section 5, Algebraic Proofs. Pause, come back when you're ready to check your work. And hopefully this was very easy for you. X was 4, R is 12.2. Collect those variables to the side with a greater number, remember? And we have -5/2. Multiply by 5 first, and we have -38. And don't forget to distribute, and we have y equals 15. Okay, so a proof today, an algebraic proof. A proof is an argument that uses certain things to prove or to show a conclusion is true. So what kinds of things does a proof use to show a conclusion is true? A proof uses logic, definitions, properties, and proven statements to show that a conclusion is true. So let's go over some properties of equality. Let me do this. What property of equality would state that if A equals B, then A plus C equals B plus C? So what are we doing to both sides here? We're adding the same value to both sides. So this is the addition property of equality. I'm sure you have the hang of it now. So if A equals B and we subtract the same value from both sides, that property would be the subtraction property of equality. If A equals B, then AC equals BC. We are multiplying both sides of the equation by the same factor. We have the multiplication property of equality. I bet you know what's next. That's right. If A equals B and we divide both sides of the equation by the same value, then we have the division property of equality. Remember in our rules where a value ends up in the numerator, that value may not equal 0. If it does, then our fraction would be undefined, right? And the fact that A equals A is a different kind of equality property. It is the reflexive property of equality. Sounds kind of funny, but we'll be using that a lot in geometry. If A equals B, then we can flip that around and say that B equals A. This is known as the symmetric property of equality. Imagine in a mirror, A equals B, and then B is closest to the mirror, so B is reflected back at you in that order. Kind of like a palindrome, right? If A equals B and B equals C, then A must equal C. This is probably my favorite property. This is the transitive property of equality. And the final one is if A equals B, then B can be substituted for any A in any expression. And that's just the substitution property of equality. Awesome properties of equality. Get to know and love them. The new ones for you this year are reflexive, symmetric, and transitive. Do you remember the distributive property? It looks something like this. We have not one but two operations in one expression. We have multiplication and addition, right? So we end up with A times B plus A times C. Okay, so two operations in one. Let's solve the equation 4m minus 8 equals 12. And each step of the way, we're going to write a justification. So this is the new thing, writing a justification for each step. So this first step is just to write the equation, and that is called given. We're justifying that step by saying we were given this equation. So what might we do next? Probably add 8 to both sides, right? And so this is the addition property of equality. We're going to now simplify. This is what we have left. Okay, 4m equals -4. To isolate m, what will we do? You got it, divide by 4, right? And that's the division property of equality. Finally, we can simplify and say that we have m equals -1. Ta-da! We've given our justification for solving that equation. You try this one and come back and check your work. Okay, so the first step was given. The next step was let's multiply, right? Multiplication property of equality, and simplify, and we have it. Let's see if you can solve this and justify each step. Go ahead and read it, come back when you're ready. So the first step is that our answer will be the temperature in degrees Fahrenheit, right? And so we list the important information. We have a given equation, that formula, and we know that the current temperature, or the temperature that we're handling here, is 15 degrees Celsius. So we're going to make a plan by substituting, right? So let's justify the steps as we go. So here's the given equation, and let's plug in our 15, right? Plug it in, right? Substitution property of equality. Now we can multiply, right? And we're just simplifying here. 9/5 times 15. Again, we can now just simplify 27 plus 32, and we end up with 59 degrees. So this is the reasoning, the justification. We're going to check our answer by substituting it into the equation. Our answer there was 59 degrees Fahrenheit. So if we put 59 degrees there, does it equal 9/5 times 15 plus 32? And check, it does. Recall from chapter 1 that when you have a length AB, you're going to see a segment over the endpoints AB, and when you want to represent the number, the measurement of that length, we just write AB. AB is like a single variable that represents that length. Notice there's no segment. So it's a number. It represents a number, but it's unique in that both endpoints are named there. Okay, so let's write a justification for each step here. We want to find x. Whoops. So the measure of the entire NO equals NM plus MO. So that's the given segment addition postulate. We're just adding the two pieces that make up the entire segment NO. So now what could we do? We see some expressions that are represented there, so we could substitute, right? And that's our substitution property of equality. Now, what can we do with that? How about if we simplify the right side? 2x plus 3x is 5x. That's just simplifying. We're ready now to collect the variables to one side, and so we can subtract 4x from both sides, right? And that's our subtraction property of equality. Notice it wasn't shown, but that's what we know happened, because 5x minus 4x gives us 1x. Now how can we get x alone? Yep, we're going to add 9 to both sides, and that's the addition property of equality. So there we have it. We have x equals 5. Now if we want to know the length of NO, what will we do? Plug it in right there. So how long is NO? That's 16. Good, 20 minus 4. Okay, let's see what the question is. And the question is find x. Okay, and justify each step. So, what do we know? We know that the measure of angle ABC is made from the measure of angle ABD plus the measure of angle DBC. So this is the angle addition postulate. And now you see this other little tidbit of information that was hiding. The entire ABC equals 8x. So now that we have that statement due to the angle addition postulate, what will we do? Substitute, plug it in. It's a good song for today, right? So we have this entire 8x equals 3x plus 5 plus 6x minus 16. And so now it's simply finding x, right? So what could we do? How about simplify the right side? And now we're going to gather our variables. We have negative x. So we must have done what? That's right, subtraction property of equality. And how can we get rid of that negative? Two options, and one of them is multiplying both sides by -1. So we have x equals 11. Awesome job. Okay, let's talk about some properties of congruence. Let me raise this up for a second. Looking here, we see a segment, EF, is congruent to a segment, EF. So this reminds us of another property of equality, and that was called the reflexive property of equality, right? A segment definitely is congruent to its own self. So figure A is congruent to figure A. The next one says that if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Do you remember what that was called? It's like a mirror, right? So it's a symmetric property. Okay, so we have symmetry. And finally, if segment PQ is congruent to segment RS, and segment RS is congruent to segment TU, then segment PQ is congruent to segment TU. Hop all the way over there. And there's that favorite one of mine, the transitive property of congruency. So remember, numbers are equal, but figures, like segments, are congruent. Okay? Let's identify the property that justifies each of these statements. See if you can do it. Come back and check your work. And yes, the simple reflexive property. And we have the symmetric property and the transitive property. And 32 equals 32, another reflexive property. Now notice we have the reflexive property of congruency here. In this, these are numbers, it's a reflexive property of equality. B shows us measures, right? Measures of angle, so those are number values, so they are equal, but C shows us segments being congruent, so that's a transitive property of congruency. So look at those little details that you need to pay attention to. And please try the lesson quiz and come back. And if you're back, hopefully you have this kind of justification. And once again, try the lesson quiz part 2 and come back. I just showed it to you. And if you're back, here you go. The justification is what I'm really looking for over here. This is the important part. And there you go. And finally, what property could justify these statements? And you're good at this now, right? Remember the difference between equality and congruency though, right? So this here, we have the transitive property of equality. These represent numbers, these variables, okay? Now we have angles that are congruent, so this is the good reflexive property of congruency. And more congruent things here. So what would you call this? And yay, symmetric property of congruency. Good job. Have a great day.